Ladies and gentlemen, hello. Today I will tell you about Three.js. Three.js is one of the open source 3D WebGL libraries. More libraries you can find in this presentation. So, despite Three.js came out earlier than WebGL, it uses some components of WebGL. WebGL is a JavaScript API for rendering 3D objects in browser without using any plugins. User can also interact with these objects. This technology is supported by all modern browsers. How it works, I can demonstrate using this teapot. So, as you can see, it's a very powerful and interesting technology. So, more examples of working Three.js you can find on its website. To prepare your workplace, first you make sure you're using browser supports WebGL. I use Chrome and Chrome supports. Create folder for your project and save the last version of Three.js library in this folder. And the last one, open and read documentation, at least partially. So, at first, we should to create starting HTML structure. It's a quite simple HTML file. Uh, we just have to set margin and padding body element to 0 and set width and height our canvas element to 100% and make two variables, width and height. And then we will add our JS code here. So, to work with this technology, we should know a few basic definitions. Scene. Scene is like scene in a movie. It's a place where everything happens. Then, renderer. Renderer is a tool which displays scenes in our browser. Camera. Camera, it's like in movie. It's an observation point. Geometry. Geometry is a form of creating object. Material. Material covers our object. Next one. Mesh. Mesh takes material and covers geometry with this material. Light. Light is a light source. We need this source to see all on the scene. And animation. Animation can move objects. So, scene. All creating objects have to be added inside the scene to see them. So we can create new scene using this code. Next, renderer. Three.js use WebGL renderer by default. So to create renderer, we should to add this code. Second, we set size our renderer to fit the whole screen here, and set background to gray instead default black here, and then append the DOM structure to our page. And one more, to start rendering, we should to use this simple render function. And all the next code have to be added above renderer function here. Camera. Um, in Three.js use a few types of cameras. First one is the most understandable is perspective. Perspective camera is, works like a human eye sees. The next one, orthographic camera. This camera uses orthographic projection. Next, stereo camera. Stereo camera use two dual perspective cameras to create stereo effects. And the last one, cube camera. Cube camera use six cameras and it makes a full 3D model of object. So you can see as it works on this picture. Perspective camera. You see these two balls have the same sizes, but this yellow ball farther from the camera and it seems smaller. On the orthographic camera, they have the similar sizes. Next one is a stereo camera. Our left eye sees this picture, our right eye sees this picture, but our brain sees this final projection. And the last one, cube camera. Cube camera makes full 3D model. To see all the rendering objects on the scene, we need this camera. First, we should create our camera with two parameters, field of view and aspect ratio. Then we set the position of our camera and the Z coordinate, and then add this camera to the scene. Geometry. Three.js provides a few types of predefined geometrical primitives. We will use three of them. First, cube, second, torus, and third, dodecahedron. Material. Material is what covers surface of our object. So, add the basic material. It's just a simple, boring material. Next one is more interesting, font material. Font material is more glossy than basic material, and the third one is the Lambert material. Lambert material is less glossy than font material. Mesh. To apply our material to our geometry, we are using mesh. So, in this string, we create standard cube. Second, we create torus with font material. Font material makes specular lights. Dodecahedron, we are without specular highlights because we are using Lambert material. So, and then we rotate our cube in two axes to show all the three its dimensions, and move cube left to clear place, then move the dodecahedron right, and add all the figures inside the scene. Light. And we also need a light. There are a few types of light. First one is a point light. It's a light bulb in our living rooms. Second one is a spotlight. It's more interesting type. It gets emitted from a single point in one direction along increases cone. Next one, directional light. It's like a daylight. And the last one, it's a ambient light. It's globally illuminates all the objects. So you can see ambient light here, and rays from the all sides, directional light and parallel rays, point light, one source of light and rays, and spotlight, one point, one direction, and increases cone. Okay, next, we define a white point of light, then set its position a little away from the center of the scene, and add it to the scene. And the next one, animation. First, we implement a helper variable, and then we increase this variable on every frame. So, first one, we rotate our cube. The second, we are scaling our torus, and the last one, we are moving up and down our dodecahedron. So, here is our resulting code. It's not a big, but it works. So, thank you for your attention.